Okay, let's take a look into 4.1 hypothesis testing for a single mean. Okay, if you still remember, when we do the estimation topic, okay, we go one by one subtopic, which is first is estimation for one single mean, right? Okay, so same goes to the hypothesis testing. We will go through the same cases in the estimation topic. Okay, so for hypothesis testing for one single mean, it's divided into 3 cases. Okay, so if you still remember, in the estimation topic, we deal with the estimation for one population mean. Okay, given that we know that the population variance or population standard deviation. Okay, so let's take a look first into the 5 steps that involve in conducting hypothesis testing for a single mean. Okay, so the first step that involved here is you need to state what are your H0 and H1, what are your null hypothesis and your alternative hypothesis. Okay, so before that, there will be 3 kind of hypothesis that can be developed. Okay, either left tail, right tail, or two tail. Okay, so but for for the null hypothesis, there will be only one kind of H0, okay, that you can use. Okay, since we want to test on mu, so our H0, our null hypothesis is written as mu equals to mu naught. So mu naught here can be any number lah. Okay, but for the alternative hypothesis or H1, there will be 3 type of statement that can be right. Okay, referring to the either is left tail, right tail, or two tail. Okay, if left tail, you can write your statement or your alternative hypothesis as mu less than mu naught. Okay, mu naught here can be any number, as I mentioned before. If right tail, you can write as mu greater than mu naught, and if the two tail, you can write as we can use symbol mu not equal mu naught. Okay, so you will decide which kind of test that you will use, either left tail, right tail, or two tail. Okay, so how to decide it based on the question. Okay, you will see to use which kind of test based on the question. Okay, so the step number 2 is called test statistic. Okay, so what kind of test that we gonna use here? We will use Z test. Okay, why we use Z test? Because we know the variance of the population or standard deviation of the population. That's why we will use Z. So the formula for Z is equals to x bar minus mu naught over sigma over square root n. Okay, so mu naught here, it's depend on your statement. Okay, so you will have the value of x bar, sigma, and also the value of sample size in the question. Okay, step number 3, you need to decide what are your critical value. Okay, so for the left tail, the critical value is negative Z alpha, and for the right tail, the critical value of Z alpha, and for the two tail, the critical value will be plus minus Z alpha over 2. Okay, so alpha here depends on the question, either you need to use 5%, 1%, or 10%. Okay, basically we will use either 1% or 5%. Okay, step number 4 is the decision rule. Okay, for the left tail, the decision rule is we will reject the H0 if Z less than negative Z alpha, or we can written as we will reject H0 if, okay, if test statistic less than the critical value. Okay, why we decide on that? Okay, if we draw the bell-shaped curve. Okay, so if the left tail, we will look into the left side of our region. Okay, so meaning that okay, we will draw our this is what we call as rejection region. Okay, so we will compare the value of test statistic and also the critical value. So if your test statistic value less than the critical value, for example, your critical value is here. Okay, so your test statistic falls in the rejection region, meaning that the value is less than the value of critical value, then we will reject the null hypothesis. Okay, that is for the left tail. But for the right tail, okay, for the right tail, okay, saya draw kat sini ya. Okay, but for the right tail, so we will look into the right hand side lah. Okay, the region will be on your right side, okay, of the bell-shaped curve. Okay, so that's why our decision rule is reject hash not if the value of your test statistic greater than your critical value. Okay, so we can write here as we will reject hash not if test statistic greater than critical value ataupun Z greater than Z alpha. Okay, so meaning that your critical value will be this is your critical value. Okay, so this is our rejection region. We will reject our hash not if our test statistic falls in the rejection region or the value of test statistic falls here. Okay, but for the two-tailed test, okay, the region will be on your both side, okay, at the right side and also at the left side. Okay, so this will be your critical value. So your critical value will be positive and negative value. This one is negative, this one is positive at the right side. Okay, so you will have option here, either your test statistic falls at the left side or falls at the right side. Okay, it will be placed in either one lah, either at the left side or the right side. Then we will reject the null hypothesis. But if your test statistic value is located at the in between the in between here, okay, meaning that at the middle of the, meaning that it was not false in the rejection region, either at the left side or the right side, then we will fail to reject the null hypothesis. Okay, so if you see here, we will reject hash not if Z less than negative Z alpha over 2. Okay, meaning that either your test statistic are located here or your test statistic are located here. But if your test statistic value is located at the middle side, then we will fail to reject the null hypothesis. Okay, so remember, we will reject the hash not if your test statistic are less than the critical value or your test statistic are greater than the critical value at the right side. Okay, other than that, we also can use decision rule by using the p-value. We will reject the null hypothesis if the p-value less than alpha. Okay, if you use the p-value, the the rules are same for the left tail, right tail, or the two tail. There only one rule here will be used if you use p-value approach. If you use by using the p-value, okay, the rules are only one. Okay, we will reject hash not if p-value less than alpha. Okay, so kita tak ada value negative or positive, we just compare the value of p-value with the alpha. Okay, and then the last step, we make a decision and conclusion. Okay, let's take a look into example 1. A company producing Everlast battery claims that its battery lasts an average of 24 months. A sample of 37 battery was tested. The mean life of these batteries was 23 months. Using a 5% level of significance, is there evidence to indicate that the mean life of Everlast battery is below 24 months? Assume the population standard deviation to be 3 months. Okay, for this example, why we decide to use case number 1, which is variance known. Okay, look at the last statement of this question. Okay, since it was said that assume the population standard deviation to be 3 months, meaning that we know the value of population standard deviation, which is sigma. So sigma here is equivalent to 3. Okay, so that's why we focus on case number 1, which is variance or standard deviation are known. Okay, what are the information that we have here? So we have here the value of average of 24 months. Okay, meaning that this one is the value of mu. Mu equals to 24, which is, this is the claims that we want to test. Okay, and then we have a sample of 37 batteries. So this one is our n. So n equals to 37. Okay, then we have the mean life of this battery was 23 months. Okay, 23 months is referring to the average or x bar of our sample. So our x bar here is equivalent to 23. Okay, another information that we have is the value of level of significance. Okay, so level of significance here is value alpha. So our alpha is 5% or 0.05. Okay, now what we want to test? Okay, we want to test, is there evidence to indicate that the mean life of Everlast battery is below 24 months? Okay, so in here you can see that it say the word below 24 months, meaning that the suitable notation or symbol that we can use here, we want to test whether the mean is less than 24 months or not. Okay, so let's go to our step by step. Okay, so number 1 is you need to decide on what are your H0 and what are your H1. So since we want to test on mean, so our H0 is mu equals to 24. So it's referring to our claims. Okay, so this one, the H0 will be ada satu saja. Okay, we use the symbol equal. Okay, then our H1 is, since tadi dia dah kata we want to test whether the Everlast battery is below 24 months, meaning that we want to test either the mu is less than 24. Okay, so you can tulis kat sini, this one is left tail. Why left tail? Because it said it was below 24 months. Okay, so tulis siap-siap. Takut nanti kita terlupa. This one is left tail test. Okay, and then our step yang kedua adalah, you need to calculate your test statistic. Okay, so I use notation TS. So our test statistic, if we refer here, Z equals to x bar minus mu naught over sigma over square root n. Okay, so our x bar tadi adalah 23. So 23 minus mu naught, our mu naught is 24, divided by sigma. Sigma tadi kita dah tahu it was 3 months. Okay, assume the population standard deviation to be 3 months. So our sigma is 3. So 3 over square root n. So our n is 3 over square root 37. Okay, we will get the value of Z here, Z here is equivalent to negative 2.03. Okay, next, right, number 3, you have to write what are find your critical value. Okay, so our critical value is don't forget to put a negative value because it was left tail. Okay, so our our critical value is negative Z alpha. So our alpha is 0.05. So no need to divide to our alpha because this is left tail test. Okay, so refer your, okay, you can refer table number 4 or table number 3. Okay, if you want to use table number 4, okay, you look at this one. You look at this. Find Z alpha. Okay, find the value of alpha is 0.05. So you will locate the value of Z 0.05 is 1.6449. Okay, so the value is 1.6449. So this one is so don't forget to put the negative sign, negative 1.6449. Okay, so next, step number 4, we want to write what are our decision rule. Okay, so our decision rule, if we look at scheme that I have right here, okay, we will reject hash not if Z less than negative Z alpha. Okay, you can write as reject hash not if reject hash not if test statistic, our test statistic is negative 2.03. Test statistic less than negative 1.6449. Okay, ni yang saya cakap tadi tu. This one is our test statistic, this one is our critical value. Referring to this one. Okay, reject hash not if test statistic less than negative 1.6449. Okay, we can write here. Awak boleh lukis kat sini. Since we are focusing on the left tail, okay, so this is our critical value. Our critical value is negative 1.6449. Okay, so our test statistic tadi kita dapat negative 2.03, meaning that it was false in the rejection region. Okay, so this we call, yang saya lorikkan ni kita panggil sebagai rejection region. If your test statistic value falls in this rejection region, meaning that we will reject the null hypothesis. Okay, so it was clear here. Our test statistic is less than critical value, or our test statistic falls in the rejection region, meaning that our decision is our step number the step number 5 is we make a decision. Okay, either to reject or fail to reject the hypothesis. So meaning that here, since the test statistic value is less than the critical value, then we decide to reject the hash not. So we reject hash not since negative 2.03 is less than negative 1.6449. Okay, so what conclusion that can be made here? We can say that the test is significant. Okay, since we reject the null hypothesis, then the conclusion is there is significant evidence to indicate that the mean life of average battery is below 24. Okay, maksudnya kat sini, since kita reject, okay, kita reject hash not, kita tolak dia. Apa yang kita accept adalah our alternative hypothesis. So we can say that there is significant evidence to indicate that the mean life of average battery is below 24 months. Okay, maksudnya kita akan accept this statement lah. So awak tulis ayat yang betul. There is a significant evidence to indicate that the mean life of average battery is below 24 months. Okay, or in simple word, we can write as mu less than 24. Okay, so make sure you write the answer in the full sentence. Okay. Okay, now I will show you the second approach, okay, to solve hypothesis testing by using the p-value approach. Okay, so the step is still the same. Okay, first you have to write what are your number one is what is your H0 and H1. So we're referring the same example tadi. Kita nak test mu equals to 24 versus mu less than 24. Okay, number 2, we calculate the test statistic. So we get the test statistic is Z equals to 23 minus 24 over 3 divided by square root 37. So we get negative 2.03. Okay, step number 3. You need to calculate the p-value. Okay, calculate the p-value. So how to calculate the p-value? Okay, so kita dah tahu our Z is negative 2.03. So now look at table 3. Okay, so find the value of Z 2.03. So 2.03 we will see here 2.03. Okay, so the p-value is 0.02118. Okay, this one 2.03 is here, so we will get the p-value is, the probability value is 0.02118. Okay, so this is how we find the p-value from the test statistic that we have calculated. Okay, so the p-value is equivalent to 0.02118. Okay, step number 4. The decision rule is reject H0 if p-value less than alpha. So alpha tadi kita dah decide is 0.05. Okay, now you compare lah. Okay, so our p-value is 0.02118. Yes, 0.02118 is less than 0.05. Okay, betul. Okay, so meaning that our conclusion is, since the p-value is equivalent to 0.02118, which is less than 0.05, then reject H0. Okay, when we reject H0, meaning that we can say that the test is significant. Okay, reject H0 ni awak kena mention nak reject ke tak. Okay, so we reject the null hypothesis. So meaning that the test is significant. Okay, so there is significant evidence to indicate the mean life of a battery below 24 months. Okay, so this is how if question asking you to use p-value approach, then first you need to find the value of test statistic. Okay, then find the value of probability for the test statistic that you have calculated, then you compare with the alpha. Okay, alpha given on the question lah. If the p-value less than alpha, then we will reject the null hypothesis. Okay, tak kisahlah Is it a left tail, right tail, or two tail? You just find the p-value, then compare with the alpha. Okay, no need to divide the alpha with 2. Okay, if you are doing the two tail test, just compare with p-value and alpha. Okay, for example 2, please proceed by yourself. Okay, then I will give you the solution for example 2 later on. Okay, same goes to example 3 and example 4. Okay, please do by your own. Okay, now let's take a look into case number 2. Hypothesis testing for a single mean. Variance are unknown, but our n is large. Okay, large here meaning that it was greater or equals 30. Okay, case recap back. Case number 1, we know the population variance or population standard deviation. Okay, so I repeat back the step involved here. Okay, so the step number 1, decide what are your null hypothesis and your alternative hypothesis. Okay, so your h0 or null hypothesis mu equals to mu naught. Okay, our h1 or alternative, it can be mu less than mu naught for the left tail. For the right tail, mu greater than mu naught. Or for the two tail, mu not equal mu naught. Okay, your test statistic, we're going to use Z here. Why we use Z? Because our n is greater or equals 30. Okay, we consider our n here large. Okay, so the formula is still Z equals to x bar minus mu naught over S over square root. And okay, kalau case number 1 tadi, we know the population variance or population standard deviation. So the notation, the symbol here is sigma. But for the case number 2, we does not know the population variance or population standard deviation. That's why the notation used here is S. Okay, so that's the difference between case number 1 and case number 2. Okay, case number 1, we know the population variance or standard deviation, but for case number 2, we does not know population variance or population standard deviation. Okay, the critical value and the decision rule same goes to case number 1. Okay, and then we also can use a p-value approach. Okay, the last one, we make a decision and a conclusion. Okay, look at example for case number 2. Past experience indicate that the time for high school seniors to complete a standardized test is a normal random variable with mean 35 minutes. If a random sample of 35 high school seniors took an average of 33.1 minutes to complete this test with standard deviation of 4.3 minutes, test the hypothesis that at the 5% or 0.05 level of significance that mu 35 minutes against the alternative that mu less than 35 minutes. Okay, so what are the information that we have here? We have okay, so the claim or the statement that given at the first is this one is the our mu naught lah. Okay, mu naught equals to 35. This one that we want to test. Okay, so we have a random sample of 35 and equals to 25. So we consider it's large because since it was greater than 33. Okay, then the statement said that average of 33.1 minutes to complete this test with standard deviation of 4.3 minutes. So meaning that for the sample size of 35, the x bar is equivalent to 33.1, and also the standard deviation, okay, s here is 4.3. Okay, dia kata standard deviation, that's why s. If it's saying variance, it was s square. Okay, test the hypothesis mu equals to 35 against mu less than 35. Okay, so it was clearly said here, we want to test. Okay, our hash note is mu equals to 35 versus mu less than 35. Okay, again, this one also is left tail test. Okay. So yang kedua, we want to calculate the test statistic value. So the test statistic value, we will use Z because again, since n is large, that's why we use Z. Z equals to x bar 33.1 minus mu naught 35 over s over square root and 4.3 over square root. Our n is 35. Okay, so the answer is negative 2.61. Okay, step number 3, calculate your critical value. So our critical value is negative Z alpha. Okay, so our alpha here is Z 0.05, which is negative 1.6449. Okay, step number 4, write the division rule. If you still remember, we will reject the null hypothesis if test statistic less than the critical value, or from the, kalau boleh lukis, okay, this is our rejection region, which is our critical value. So we will reject the null hypothesis if our test statistic falls in the rejection region, or our test statistic less than the critical value. Okay, if we look the value of our test statistic here, kita dapat negative 2.61. Our critical value is negative 1.6449. Our test statistic is negative 2.61, which is falls in the rejection region. Okay, so this one is negative 2.61. Okay, so our step number 4, reject our decision is reject hash note since negative 2.61 less than negative 1.6449. Okay, it was fall in the rejection region. Okay, when we reject the null hypothesis, so meaning that, okay, we can conclude that the test is significant. Okay, test and significant, and there is significant evidence to indicates that there is significant evidence to indicates mu less than 35, or you can write in sentence lah. We can say that the time to complete the test is less than 35 minutes. Okay, please complete for example 6. Okay, the working will be given later. Okay, now let's circle into case number 3. Hypothesis testing for a single mean. Okay, variance are unknown, but our n is small, less than 30. Okay, so the step is still the same. You need to define your H0 and H1. You need to calculate. Okay, I want to emphasize here the test statistic. Okay, for case number 1 and case number 2, we use Z. But for case number 3 here, we will use T. Why we use T? Because we does not know the population variance or population standard deviation. But the sample size is small, less than 30. That's why we will use T here. Okay. So the test statistic, the formula is given by T equals to X bar minus mu naught over S over square root N. Dia sama macam case number 2 tadi kan. Formula dia cuma tadi tu T, tadi tu Z, this one is T. Okay, so your critical value for left tail, negative T alpha n minus 1. For the right tail is T alpha n minus 1. But for the two tail, plus minus T alpha over 2 n minus 1. Okay, don't forget, If you are using the two-tail test, okay, meaning that your H1 is mu naught not equal, you use the symbol or notation not equal, then your alpha should be divided by 2. Okay, only for the two-tail alpha, you should divide by 2. Okay. Okay, then for the decision rule for the left tail, we will reject H naught if T here less than the critical value. Okay, we will reject if test statistic less than the critical value. You also can write here, reject H naught if test statistic less than critical value for the left tail. For the right tail, reject H naught if the test statistic greater than critical value, which is the critical value is T alpha n minus 1. Okay, but for two-tail, okay, we will reject the the H naught if test statistic less than negative CV or test statistic greater than critical value. Okay, this one untuk yang negative, this one yang positive. Okay, ingat kena buat plus minus sebab dia dua side. Okay, either at the right side or either at the left side. Okay, untuk yang left tail ni dia memang dekat sebelah kiri lah. Okay, untuk yang right tail dia di sebelah kanan. Okay, then last sekali step number 5, we make a decision and conclusion. Okay, again, if we reject H naught, okay, we can say there is sufficient scientific evidence to conclude what? Okay, kita ambil statement H1 lah, sebab kita tolak, kita buang H naught ni, yang kita nak terima adalah H1. So that's why we use statement of H1. But if we fail to reject H naught, maksudnya kita tak tolak H naught tu, kita terima, kita accept H naught tu. So there is sufficient statistical evidence to conclude, guna statement H naught. H naught kita apa? Mu equals to mu naught. Tulis balik sahaja. Tail. Okay, let's take a look into example 7. Okay, example 7. The specification for the production of a certain alloy called for 23.2% copper. A sample of 10 analyzed of the product showed a mean copper content is 23.5% and standard deviation of 0.24%. Can we conclude at 1% significant that the mean copper content is higher than the required specification? Assume the copper content is normally distributed. Okay, so what are the information that we have here? Okay, we have our mu naught is 23.2%. Okay, mu naught equals to 23.2%. Okay, this is the value that we want to test. Okay, we have n equals to 10 sample with the x bar value is 23.5 and standard deviation for this sample is 0.24. And then the value of alpha is 1%, 0.01. Okay, so we want to test whether the mean copper content is higher than the required specification. Okay, so this is the keyword higher. Okay, now our step number 1, you should state what are your H naught and H1. Okay, so we want to test on mu equals to 23.2 versus mu greater than 23.2. So greater, since it was greater, so this is the right tail. Right tail test. Okay, step yang kedua, we need to calculate the test statistic value. So our test statistic value is, we're going to use T equals to x bar 23.5 minus mu naught 23.2 over S over square root n, 0.24 over square root 10. So we will get the answer for the test statistic is 3.95. Okay, step number 3. Calculate the critical value. So our critical value is right tail. So kalau tengok yang kat depan tadi, we can return as T alpha n minus 1. Okay, alpha, you don't have to divide by 2 since this one is right tail. So T 0.01 n minus 1 is 9. Okay, so we should refer table T. Okay, so table T is here. So look at alpha 0.01. So this one, alpha 0.01 and n minus 1 is 9. Okay, so the value is 0.01 and n minus 1 is 9. This one, 2.821. So our critical value is 2.821. Okay. Step number 4, write your decision rule. So our decision rule is reject hash not if test statistic greater than the critical value. Okay, kalau kita lukis our T, keep sebelah kanan lah. So this one is our rejection region. This is where the critical value are located. Okay, so our critical value is 2.821. Okay, so that's why our decision rule reject hash not if the test statistic greater than critical value, meaning that if your calculated test statistic are greater than 2.81, which is false in this rejection region, meaning that we will reject the null hypothesis. Okay, so we can see here our test statistic is 3.95. Okay, meaning that is greater than 2.81 or it was false in the rejection region. So meaning that our decision is will reject the null hypothesis. Reject hash not since 3.95 or the test statistic is greater than 2.821. Test statistic greater than the critical value. Okay, so what can we say? Test is significant so we can conclude. Okay, tengok balik kat soalan. Dia tanya, can we conclude at 1% significant the mean copper content is higher than required specification? Yes, so we can conclude that the mean copper content is higher than required specification. Okay, since kita reject tadi hash not kan. Okay, so statement yang kita akan terima adalah H1. So we can say here the test is significant, the mean copper content is higher than required specification. Or you can write as mu greater than 23.2. Okay, please complete example 8 and example 9 by your own. Thank you.